Okay, moving on to passage 2. So I'll do a little kind of scan of the experiment or the study or whatever it is, just to get my bearings, just to see if I feel like I want to read something, and just to kind of get an idea of the figures. I usually just will take about maybe 15-20 seconds just to scan it and just to get an idea. And again, I'm taking my time because this is a sort of teaching video. In the exam, I would just scan it very quickly and just get some idea, just to get my bearings. But here we go. I'm just going to look at the figures, and I'll increase this a little bit so you can see. So figure 1 down here, along the bottom, it has distance from the volcano crater. Fair enough. Up here, percent by mass of clasts. I have no idea what clasts are, and I don't really care. Figure 2 over here, I like the fact that the figures are similar, because they tend to be easier to interpret or compare and contrast or find information in than when they have like a bar graph like this, and then they have like a line graph as the second one. So I'm pleased that the graphs look the same. This figure number 3 below it, I don't like that much. And it says, example, 83% of the total mass of the combined samples is accounted for by class and matrix particles having diameters of point. I don't know what that means, and I don't really care. But I will, because of this one, I am going to read just this little bit here. If it was just the two, figure 1 and figure 2, I probably wouldn't bother, because they're probably going to be easy enough to read. But just because of that third one, I kind of want to get my bearings just ever so slightly. And again, this is going to take 20 seconds maybe in the actual exam. I just scan figure 1, scan figure 2, look at the X and the Y axis to see what's going on. But that third one has kind of thrown me a little bit. I don't like it because it's so different. So I'm just going to read, these are 3 sentences, it'll take seconds. All right, I'll increase it here. Lahar is a flow of water-saturated volcanic ash. Right, a lahar, again, it's in italics, so hold it. Water-saturated volcanic ash and rock, a lahar deposit, formed once the flow stops, consists of clasts, oh, now we know what clasts are. They're rocks having diameters of greater than 16 millimeters, embedded in a matrix. Oh, we know what matrix are. A mixture of particles having diameters of less than 8 millimeters. All right, that's as much as I need to know. I don't really need to know anymore. I'll read anything else if and when I need it. I'll just be guided by the questions. All right, so we come over to the left-hand side, and we're looking at question 6. According to figure 2, all right, so I'm just going to sort of give you since this is the first question, I do this step by step. So according to figure 2, that's going to be step 1 is finding, I need a pen. Step 1 will be finding figure 2. As the distance from the volcano's crater increased, so that'll be step 2. What does that look like? Step 3, the percent by mass of silt and clay particles in the matrix of the samples increased only, decreased only, increased, then decreased, decreased, then increased. So we've got 3 steps. Right, that's all. Do those 3 things, and then you should be able to find the answer. And that's, if you can get into the habit of seeing it like that, of marking the steps, and then just following the steps, and seeing where it leads you, I promise you, if you do enough of these, 9 times out of 10, and probably even more than that, it will lead you to the answer without too much problem. So, we shall do it step by step. Step 1, find figure 2. Oh, I already circled it. Okay. So we'll come over to, I'll increase this because I think we're only dealing with figure 2. So figure 2 is here, so we know we're in the right area. As the distance from the volcano's crater increased. So I'll look, here's the distance from the volcano crater. It starts at 0 and it is increasing this away. All right, so that's the way I'm looking. I'm looking at what happens from left to right. That's step 2, done. Step 3, percent by mass of silt and clay-sized particles in the matrix of the samples, increase, decrease, whatever. So now I need to do step 3, What is percent by mass of silt and clay? What are they doing? And then we have this handy dandy key. Because I don't know what these shaded areas are, this, and then it goes to stripes, and then it goes to a solid grey. But this tells me, the key tells me. And here we see, and again, we're just matching words in the question to stuff in the passage. There's silt and clay right there, it's the dark one. So what's it doing? As it goes from left to right, what is it doing? This is kind of large, smaller, 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 smaller. There we go. That's number 3. Percent by mass, what is happening to it? Is it increasing only? No, it's definitely not. Is it decreasing only? Why, yes. Yes, it is. It is decreasing only. And that is a nice question just to show you, you do it step by step, and 9 times out of 10, you're going to get the answer. And it's G.